Learning engineering, it's continual evaluation of your product, understanding what works and what doesn't work, using principles of how people learn to make changes to your product. It's basically what EdTech Recharge does. So it's more of a formative evaluation, which means you're evaluating your product as you're still developing it. You're keeping in mind the science of learning and the science of motivation while you're developing your product, and you're collecting data and making changes based on those data. So a great example I have here, Duolingo, they do a lot of learning engineering. So if you've ever used their app, they're trying to figure out what's the best way to teach different languages. And they often embed experiments within their app, and they call it A/B testing. So one group of people is randomly assigned to this way of this algorithm, and then another group is randomly assigned to this other algorithm. They collect the data, analyze the data, and then decide, okay, people learned X language better with algorithm A, so now we're going to implement it.
So this is my breakdown of what are the different steps with learning engineering. If you haven't guessed so far, with research, everything's about how specific you can get, how systematically you can plan it, and how cleanly you can execute it. That's like the 3 golden rules of research. Learning engineering is not much different. Everything with learning engineering is focused on what data you're collecting and how can you use it to inform your product design. So the very first step is to decide the purpose of why you're engaging in this. Is this simply to test for efficacy? Is this to test if a specific feature is more useful? Is this to test, hey, what's the user experience? It is important for you to decide what is the purpose of that specific learning engineering project as you're starting out, because that can influence decisions further down the lane. A second step for learning engineering is to decide the frequency of data collection. Are you going to be able to collect data on a daily basis, on an hourly basis, on a monthly basis? This is also important not just for you to actually collect the data, but to double check that your database actually stores it for that long. I think some of the earlier startups have a tendency to clear up our data spaces so we don't use it too much, and that can sometimes be an issue if you actually need data going back a month. You also want to be thinking about what is the timeline for the goal when you're thinking about how frequently you want to collect data. If you are planning your next version out in 2 months, you're not going to be able to collect data for a full month and then analyze it and then iterate and then move through. So you want to think about what are the stakes attached to that decision. If it's a high stakes decision, you want more data. Depending on how many users you have, that could be a short time, but it could also mean you want to plan ahead of that big decision date to actually collect that data. The third step is to decide the outcomes and outputs that you want to measure and track. And step 4, we're thinking about, can you measure these outputs? Can you measure these data in your platform? The audit and plan is basically you taking stock of what data do you need? What data are you already collecting? What data should you be collecting? When and how? It's basically you just working through the data trail to see, do you have everything you need in place? If not, what do you need to fix? How long would that take? You also want to check when you're doing the step 4 of audit and plan that your data is speaking with each other. That one database has, let's say, student ID. That same student ID is being connected into another database if you have multiple databases. So be sure that you are collecting the right pieces of data, but they're also syncing together in a clear way. Think about it like when you're using HubSpot. You want to have consistent information for all your customers, so it all syncs up neat. It's the same thing when you're doing learning engineering. You want all of the student and teacher data to be identified using a single ID number across databases so you can easily pull in through them. The 5th step is the implementation. Implementation can happen with your technical engineers if you're thinking about how do we bring in this information or how do we collect this information from the platform. I would also recommend reaching out to a researcher ahead of time, whether it's us at EdTech Recharge or someone else interested in your field, to double check that you have chosen the right kinds of data points that you're collecting and that you're collecting enough data points to actually run or test the assumptions you want to test. After that comes the analysis and application pieces. Analysis is ideally always supposed to be guided by the assumptions you're testing. And this is why your assumptions worksheet is like a gold mine, right? You want to write down, I'm collecting all of this data. Think about your purpose. What are the related assumptions? Then analyze, keeping in mind those assumptions. Are you allowed to do exploratory analysis? Absolutely. But the more intentional you are, the more specific and actionable your data and your insights are going to be. That takes us to that last step of actually applying the findings we get from the data to do two things. One, either you're thinking through, hey, I didn't really get what I wanted, so maybe I'm thinking about the wrong outcomes, or maybe I'm thinking about the wrong way to collect these outcomes. Or you're going to be rethinking, hey, maybe the design needs to be tweaked, or perhaps even the product itself needs to be tweaked. If you're like, hey, my method is strong, my outcome definitions are strong, my product design needs to change. This is what Duolingo does with their algorithm piece, is when they test these A/B testing, they compare final learning outcomes between the two to see which is a more efficient way of learning, which is a more effective way of learning, and then implement that into their bigger and broader program design. The entire goal of learning engineering process is very focused on, yes, we have some evidence upon which you've constructed your logic model, but learning engineering will help you test if those assumptions about the evidence being relevant to your product actually is true or not for your specific use case scenario.
What data should you collect? This depends on the outcomes that you've listed in your logic model, but here's some examples. It could be things like time on task, again, specifying what does that mean? Is that from logging in to logging off? Is it from initial click to maybe you're idle a few seconds? Highest level completed, performance on the first level, average number of minutes spent per session, average number of levels completed per session, length of time using the product, across months, year, days. So again, thinking about what makes sense for your specific, if it's a platform or a product that you have. And then I'm calling this leveling up the data collection. So it might be not one data piece, but multiple data pieces that you need to combine together to get to another outcome that you care about. So maybe it's, what does the user do after failure, after they get something wrong? Do they go back and revisit old content? Do they just forge ahead to the new content? How long on average are users idle on a platform? So again, this takes kind of multiple pieces of data together to create your measure. So how can you collect data? There are programs out there like Mixpanel, which will let you start collecting metrics from your platform. Again, if you go with like a pre-made program like Mixpanel, you are limited by what exactly you can collect. But if you don't have any engineers on your team or you're all strapped for time, this might be a good way to start. Or you can work with your engineers to set up data collection. And most of the time, the output is likely in a CSV or a JSON file. So I tend to like having things in CSV format because then the person who does the analysis, it might be a data scientist you have, it might be a data engineer, or it might be an external researcher. It's pretty easy to manipulate CSV files. So what does it look like? A lot of times you'll have a CSV file with a bunch of rows and columns. And oftentimes you'll get perhaps different data files that you need to stitch together into one big data file. So you can imagine maybe if you're interested in looking at standardized test scores, you might be getting those data from the school, the state, the school district. They're going to give you one set of files. Then you might have administered student surveys. So you're going to get another set of data, another Excel file or CSV file, and then you might get some backend data. So here's an example of what backend data looks like. And again, I want to reiterate, this is part of that planning step. So Kripa had mentioned that you want to decide on the frequency of your data collection and decide on the outcomes and outputs and document This is something that you're going to be deciding on before you implement it. So you would decide on this with your data engineer or data scientist. So each column is maybe a different variable, and each row is what they call a different event. So you can see here that we have an event code. So these are a bunch of numbers that, looking at it, I have no idea what these mean. Like, what's 2020? What's 3010? You might have a separate code book that says, okay, 2020 means this, 3010 means that. You might have something like a date, a timestamp. You might have something like game time that's measured by the computer, and et cetera, et cetera. And other ones that I want to focus in on, this ID column. This ID column is so important. So this is going to tell me that person 411 or kid 411, all of these rows of data are associated with the same person. And I'm going to hope that if I have survey data, that I'm using the same IDs for the kids that I administered the survey to with the kids that are doing the backend data, so I can link. So I can say kid 411 on the event log data matches kid 411 with the survey data, so that you can connect those two together. And so you can imagine that these kinds of data files can get really big. So I just showed you, what is it, like 8 rows of data? The original file probably contained 10,000 rows of data. So these things get really big really quickly, and they can get, lots and lots of columns. So yeah, if you want to look at the school level, I just put, maybe your school level data sets, like a lot, only has 3 columns where you have school ID, urban and rural, reduced, free reduced price lunch. And then you could have a student level data set that has a student ID, a school ID, again, so you can match the school ID with your other school level data, things like gender, race, ethnicity, age, et cetera, things that you would collect from a survey. So we always advocate for using multiple methods to collect your data. So combining backend data with something like a survey is really great. Then you can look at things like gender differences or age differences. So hopefully that gives you an example of what the data could look like.
One last note about data and just research in general, but especially data. Always start with your why. That's what we did when we started with our long-term impact. Go into the what, then the when, and lastly, the how. Very often it's easy for us to do this in the reverse way, saying like, hey, I can collect this data on my platform. I can collect it on a daily basis, and this is what it tells me. How do I use it? That's not a bad approach. It just means you're exploring more, and you might fall trap to what you were saying, like the self-fulfilling biases kind of piece. When you start with the why and then reverse engineer that process, that's going to help you be a better learning engineer.